Here is our next question. We have 2 sine x cos x is equal to the square root of 3 cos x. Okay, so with this one, we've done something similar. We want all our trigonometric ratios on one side, everything else on the other side. So what I will do is I will take this square root of 3 cos x to the other side. When you see it like the square root of 3 cos x, it means they're multiplying. It is square root of 3 times cos x. So I subtract this on both sides, and this is what I should have: sine x cos x minus square root of 3 cos x. This is equal to 0. Okay, so I have everything on one side, so I shouldn't divide by cos x. It might be tempting to divide by cos x, but that cancels out some solutions. We will not have a complete set of solutions if we divide by cos x. Okay, so what we do is we take it to the other side by subtracting, and then we factorize just like one we did previously. So now that we have it on that side, we can see cos x is a factor here and it's a factor there. So I factorize it out. So I have cos x. Then what am I left with? 2 sine x minus square root of 3 is equal to 0. Then again, I have two terms multiplying and the answer is equal to 0. It means the first one is equal to 0, or the second one is equal to 0. So this one, we've done something similar. You should remember the solution. We said when we have 0, cos, sine, tan of something is equal to 0, then it means your solutions lie on the axis. Your answer will either be 0, pi over 2, 270, or 3 pi over 2, 180, or pi. Okay, so when I look at this one here, cos x is equal to 0, this I should know x is equal to pi over 2 because I'm working with radians, or x is equals to 3 pi over 2. So I'm not going into much detail about this one because we did it already. Okay, so I look at the second one. I'm just going to split my page up a little bit. So when I look at that one, I need to make sine x the subject of the formula. So I have sine x is equal to the square root of 3 over 2. Okay, then I need to find my reference angle. Now you'll see I'm not writing down the headings, but I'm still following the procedure. So my reference angle theta is equals to sine inverse of square root of 3 over 2. I forgot to work out the quadrants, but the steps are interchangeable. So we can find the reference angle, then find out in what quadrant it is in. So here, square root of 3 over 2, I use my calculator. Can you see? Say sine inverse of square root of 3. Hold on. Sine inverse of square root of 3 over 2. Is that typed in correctly? Okay. And then you can see my angle is 60 degrees, but I want an angle in radians, so I need to remember that 60 degrees is equal to pi over 3. So my reference angle is pi over 3 radians. So I need to work out the quadrant. So you see it's interchangeable. You can work out the reference angle, then the quadrants, and then put those two together to get the solution, or determine the quadrant, the reference angle. Either way, you will still get the same thing. So now I look at this, what I have over here. This is square root of 3 over 2. It is positive, and this is sine. I need to say in what quadrants is sine positive in. It will be the first quadrant because all of them are positive in the first quadrant. And in the second quadrant, that is where sine is positive. Sine is positive in the first quadrant, all of them are positive there, and only sine is positive in the second quadrant. Now if it is in the first quadrant, then x is just equal to theta, my reference angle, and if x is in the second quadrant, then x is equals to pi minus theta. That is the definition of an angle in the second quadrant. Now here now that I've established the definition, I can give the actual values. If x is equals to theta, it means x is equals to pi over 3 radians. And here, if x is equals to pi minus theta, this means this is pi minus pi over 3. Okay, so here again, we're just counting. If I have 1 pi and I remove a third of the pi, how much pi do I have left? I have 2 pi over 3 radians. Okay, so those are my solutions. Now that I have everything, I worked out the solutions for cos x, and then the solutions for sine x is equal to square root of 3 over 2. It's always nice to just list the final solutions. So solution, and I have x is equal to pi over 2, so I'm writing down my solutions from cos x, or 3 pi over 2, or now the solutions from sine x, it is pi over 3, or it is 2 pi over 3. So the order you list them in doesn't really matter, as long as I can see all 4 of them are there. It's good. I think it's helpful to list them in increasing order. So you will start with pi over 3, pi over 2. Let me just write that. So it's best, it's always good, it's helpful for somebody marking it if you write it that way. So it's pi over 3, then it's pi over 2, then it's 2 pi over 3, and then 3 pi over 2, just so that it's easier to mark. But just like that is also fine. Okay.